Hello everyone, this is Anika Mishra. I study in grade 7 and welcome to Scope Edification. Today we are going to learn distribution of electron and an interesting rule called 2n square rule. If you like the video, please support me. And now let's get into the video. Electronic configuration. The configuration means the arrangement of electrons and electronic is electrons. So the arrangement of electrons is known as electronic configuration, and electronic configuration is also called electronic structure. The arrangement of electrons in energy levels, shells or orbits around the nucleus is known as electronic configuration. Now 2n square rule. Okay, there's a rule called 2n square rule. What is this? So 2n square rule helps in the determination of the arrangement of electrons. As you can see here, this is a structure of an atom. Okay, so we can assume that this is a community, a society. Okay, and the center, the nucleus, we can assume that this is the clubhouse of the community, and these are the shells and these are the electrons. So the shells are houses in the community. So house number 1, house number 2, house number 3, house number 4, n number 1, n number 2, n number 3, and number 4. So n, what is n? N represents principal quantum number, or we can say shell, orbits, or energy levels. Okay. Now each shell has different names. Okay. So this shell, the shell close to the nucleus. Okay. First shell is K shell, second shell L shell, third shell M shell, and the last shell N shell. Okay. Now the last shell, outermost shell, has a specific name which is valence shell. Okay, valence shell electrons. So this is the specific name for N shell, and this helps to calculate the valency. And the second last shell, M shell, also has a specific name which is penultimate shell. Okay, K and L shell don't have any specific name. Now, the shell close to the nucleus has less energy, and the shell far from the nucleus has more energy. Okay. Now 2n square rule. Each community, each society have different rules. Okay. Same way this community has a rule which is 2n square rule. So 2n square rule is what? It helps in the determination of of the arrangement of electrons. I'll explain you this more. So the first shell, okay, K shell, it is close to the nucleus, it has less energy. Okay, so it is small. That's why only two members can stay in this house, meaning only two electrons can be in this shell. Okay, and now the L shell. Okay, it is a little more bigger. Okay, now this will have more energy. It is a little more bigger. So 8 members can stay in this house, meaning 8 electrons can be there in this shell. Same way with M shell. M shell is a little more bigger. It has a little more energy. So that's why 18 members can stay in this house, meaning 18 electrons can be there in this shell. And the last shell, it is more bigger, it has more energy. So 32 members can stay in this shell, meaning 32 electrons can be there in this shell. Now, as I told that the shell close to the nucleus has less energy, and the shell far from the nucleus has more energy. So that's why these shells are also called energy levels. Each shell has different and fixed energy. Okay, so this 2n square rule was made by two scientists, Bohr and Bury. Okay, and this formula helps in the determination of arrangement of electrons. Now, how can we calculate this 2, 8, 18, 32? Come, I'll tell you. So n is principal quantum number. Okay, or we can say energy levels, shells, orbits. Okay, so if we want to calculate for the K shell, okay, first shell, so we will write the shell number. Okay, so 1. In place of n, we will write the shell number, which is 1. 1 square is 1, and 2 into 1 is 2. So for this, it is 2. Same way for L shell, we will write the shell number 2 here. 2 square is 4, 2 into 4 is 8. M shell, we will write shell number 3 here. Okay, 3 square is 9. Okay, and 2 into 9 is 18. And for N shell, we will write the shell number 4. 4 square is 16. 2 into 16 is 32. Okay, this is how we calculate. So why these shells or orbits are called energy levels? So first shell, okay, the shell close to the nucleus has less energy. Shell far from the nucleus has more energy. So I'll just go back there. These are the shells. Each shell has different energy. So first shell less energy, last shell more energy. These are the levels of energy. Okay, levels of energy. Second shell will have a little more energy. The third shell will have little more energy, and the last shell will have little more energy. So these are the levels of energy. So that's why these shells or orbits are called energy levels. These orbits are associated with different energy, and each orbit has different energy. So these shells or orbits are called energy levels. So what did we study today? We studied the electronic configuration. Okay, the arrangement of electron is electronic configuration. We studied 2n square rule. 2n square rule is helps in the determination of the arrangement of electron. We studied the what is n is principal quantum number. Okay, we studied how can we calculate that how many electrons can be there in a particular shell. Okay, and what is the specific name for the M shell and N shell. Okay, so all of this we studied in this video. Now in the next video we will study the electronic configuration of first 20 elements.